Well, welcome here, everyone. We're really excited to have you join us today. We are just past the top of the hour, so I'll kick us off. Welcome to FME Realize in the Real World, the Power of Spatial Computing in Action. Today, I'm joined by our three presenters, Sinai, Dan, and our special guest, Posh from HDR Inc. And I'll pass things over to Sinai to kick off our introductions here.
Sure. Hi, everyone. My name is Sinai Mendoza. I'm a customer solutions specialist here at SAFE. I've been at SAFE for about 5 years now, and I'll pass it over to Dan.
Hey, my name's Dan Minnie. I'm a customer solutions specialist as well on the same team as Sinai, and I've been at SAFE for around 4.5 years now.
And my name is Posh Sapakmai. I am the Aviation Digital Delivery Lead at HDR. And on this presentation, I have a dual hat here. I'm also an embedded staff at Philadelphia International Airport, focusing on BIM, CAD, and GIS.
Amazing. Thank you, everyone. And I also want to take note that we do have Dimitri on the call with us today. He is our FME Realize expert. So please take advantage. Don't hesitate to ask any questions as we go in that questions tab on the bottom right. And then we also have Evie joining us as well. So lots of support today for questions. And then we'll also have dedicated time at the end for live questions. So yeah, do get your questions in as we go here. And then if you have any audio or video issues during the webinar, you can click that help button on the bottom left. It's got 4 simple steps you can take. The first of which just being a quick page refresh usually does the trick. And we have our react button on the bottom middle. Share your reactions with us as we go. We love to see how everyone's feeling and reacting to the content. Keeps us fueled, keeps us going. Thanks, everyone. That's fun to see. Leave any comments there, any ideas, and keep letting us know where you're joining from. And if you do wish to download the deck, you can either click the button on the top right of the PDF or under handouts in apps. You can download it there as well. Okay, so at this point, I'll prompt our presenters if they can turn off their webcams to save on bandwidth here for the remainder. And I will pass things over to Dan for our agenda.
Awesome. Thanks, Elizabeth. All right, so yeah, we'll start things off with an introduction about what FME Realize is, give you a bit of an overview of the product for those of you who aren't familiar. We'll then talk a little bit about the FME platform. Again, for anyone who's not familiar with the platform, it'll be just a quick overview of who we are and what we do here at SAFE. And then we'll talk about preparing data for AR. So that first step is key in allowing FME Realize to really flourish. So we'll talk about data quality, QA, and also using FME Realize as a quality assurance tool as well, kind of flipping that one around there. We'll then talk about creating Realize workflows, how that's done, the different steps involved there, from creating your workspaces in Form to publishing up to Flow and viewing those in FME Realize. And then we have Philadelphia's Airport's Spotlight, which will introduce their use case of master utility drawings, CAD and GIS workflows, and how they're using FME Realize in the field. So really what we're focusing on here with FME Realize is understanding how we can view our data, and that's in the real world in front of us in augmented reality. So we're not viewing it in charts or dashboards. We want to see the data in the field where it actually lives. And with FME Realize, we can experience that data in the field in a new way. And this is built all on top of our existing FME platform. So for those of you who already have FME Form and FME Flow, this will be a mostly straightforward process to get into FME Realize. So FME Realize allows us to see, understand, and interact with our data in the real world. It's powered, again, by FME Form and Flow entirely. So it's all running on the same engine. You're building out the same workspaces to power your models that you're viewing in the real world. And FME Realize completes FME's spatial computing platform, where FME has the strongest support for spatial data. So really just delivers an immersive experience of spatial computing. You can take those CAD, GIS, PDFs, pull that through into FME, and then view that in the real world, take action on those assets, or just be able to view your assets in the field. So the whole experience is brought together by the whole FME platform. So we have FME Form, which allows us to author our workspace. We can perform any data transformations, any spatial filtering, or QA in FME Form when we're building out our workspace. And once we've completed that workspace, we've generated 3D models from our 2D data, or we already have 3D models. We can then deliver that up to FME Flow, which can then provide the data to FME Realize. So the data will flow between Flow and Realize, between you using your mobile application, which is FME Realize, and connecting to FME Flow. And today we'll also be discovering how Philadelphia Airport is taking one of their existing workflows, which is their CAD to GIS MUD workflow, and how they're transforming this into smarter decisions and integrations using FME. So let's talk a little bit about the FME platform. We kind of touched on this a little bit already, but we do have 3 different products here. Of course, we'll be focusing on FME Realize on the right there, which is our mobile application available on iOS. It allows you to view your data in the real world, and that is powered by FME Form. This is our no-code data movement and transformation interface where you author and build your workflows. And once you've built those workflows, you can publish them up to FME Flow, which allows you to automate, schedule, manage, and just bring those workflows to life at the enterprise level. And we also have a FME Flow hosted, which is a safe software managed FME Flow instance if you don't want to have to deploy your own FME Flow. And we have unrivaled data support. This is one of the strong suits of FME and safe software, and really plays into the role of FME Realize, where we're able to take almost any data type, pull that through FME, and then transform that in a way where we can view that in the field with FME Realize. So preparing data for AR, this is the step that's going to be occurring before you actually start building up those workspaces where you're generating your models, and before you publish those up to FME Flow. The first step here is to gather your data in the FME Realize process. So you might want to think about common data sources. We've already mentioned GIS, CAD, and PDFs. You might have asset management systems. You might have engineering models. Anything that's an asset that you or your field crew want to visualize and see in the real world could be used in FME Realize. You may already have existing workspaces that you've built out in FME as well that you can repurpose and leverage for FME Realize. So a lot of the work is already done. You just need to take that data and transform it into the FME Realize models. And QA/QC considerations are mainly based around geometry, because we are generating those models to view in the field. We might need valid and correct geometry to have correct information that we're viewing in the field. And in other cases where it might not be obvious if your data is correct, you might not know if the locations of your assets are correct. FME Realize can also play a role where it's a QA tool. So you can take that data, plug it into FME Realize, and view it in the field. And that's a way to actually see your data and double check and reference if that data is in the correct location. Transforming the data happens in FME form, and this allows us, again, to prepare that data for FME Realize, and we'll go into more detail in our creating Realize workflows section. Lastly, we published our workspace to FME Flow. FME Flow is the engine that runs our workspaces, processes the data, and generates the augmented reality models ready to view in your FME Realize mobile application. And then once an FME Realize workspace is ready, we can go ahead and create our Realize app. So in this section, we're mainly focusing on the QA/QC process. So the first step here is FME Realize is only as good as the data you feed it. Of course, in some cases, the quality of the data might not matter. We kind of mentioned using FME Realize as a QA tool itself, but you can imagine an example where you're pulling diameters or heights from attributes, then this could lead to models in FME Realize that are misleading, like you can see in the image on the right. You could have loss of trust from stakeholders, and decision makers might be acting on incorrect information. So it's really important to have high quality and valid data. So how can data be prepared for augmented reality? We need to understand our data prior to the writing process. Do we need to create geometry from attributes such as heights or diameters? Are these values consistent and correct? And we also need to understand our goals. Who is the audience that we're presenting this information to? And can we distill this information to the appropriate audience? Not all data that we have within our data sets is going to be relevant to those working in the field. We also need to understand our data. Before diving into the authoring process with FME Realize, we need to take time to understand the structure, the quality, and the intent of our data. So how can we prepare our data for augmented reality? We can take our first step by cleaning our data. So this might include steps like standardizing the units before converting geometry to 3D. That kind of hits back to the image we had a couple of slides ago, where you have a pipe that has obviously an incorrect diameter. If we're generating that diameter and that 3D model within FME from 2D data, then that could be one of those issues that we're going to be running into. So typical steps might include standardizing your units. You might want to ensure that measurements are standardized before converting geometry into 3D models. So you will want to check that your units are all the same, whether that's meters, millimeters, feet, inches, whatever measurement you're using. We might also want to validate attributes. So we can use transformers to check for missing or invalid spatial attributes, again, such as diameters, heights, elevations, those sort of things. And we can also leverage transformers to perform spatial attribute verification. Again, these attributes are driving the 3D model generation, and they're just as critical as the geometry itself. We can also look into optimizing our geometry. We can simplify or generalize complex geometries before converting them, and this will allow us to have less complex models, which are quicker to generate and process through FME. We may also want to perform spatial validation. So we can use the geometry validator transformer to perform topology checks and other spatial validations. This is a great tool because it has a ton of preset tests that you can perform. So you don't have to go through and specify, any specific test yourself. You just go through, click, choose which one you want to use, and you can see how that's affecting your data. And it'll give you insight into what issues are present on your data as well, so you can go through and fix those. The geometry filter is another great tool. So you might want to filter out specific geometry types. Say you just want to work with lines or polygons before transforming them into 3D models. We can also look at using spatial containment. So we could have spatial filters or clippers to reduce the size of our models. We'll also want to check for consistent coordinate systems. If we have data that's reaching our writers that comes in different coordinate systems, then we're going to have some missing data in that case. So we did touch on this a little bit earlier. Using FME Realize as a QA tool is a very valid and powerful use case. A lot of the time, we're not going to know if the data that we have is actually correct or if it's in the right location. We're assuming that all of our data is in the correct location, but as you can see on this image on the right, you might have cases where something like a fire hydrant is offset from your data by a foot or so. So FME Realize could be used for both that visual validation where we can see how our data appears in the real world, and we can let users confirm the quality of the data and report errors back to the office. So we'll show that in a quick video here. And this is using real data from the city of Coquitlam, so just a couple cities over from where our head offices are located. But you can see in this data set, we've got things like manholes, things like our sewage pipes, and all of these are in the correct location. We can use these as references as we're walking around. But if we look back to that fire hydrant, you're going to see that some things are offset. So we can adjust our model, we can move it around to kind of line it up with these other assets we have here. But looking at that fire hydrant, you can clearly tell that it's offset and that there are some issues. All right, so we'll hop over to the next section and I'll pass it off to Sinai.
Thanks, Dan. Okay, so in this section, we're going to move from clean data to building the actual 3D experience. We'll focus on how the workspace creates these interactive and spatial experiences and how they connect directly to the AR app, FME Realize. So the first couple steps in the process were all about quality and readiness. And now we're going to focus on the last 3 steps, which are transformation and delivery. And these are the stages that bring that 3D content to life. So each of these steps are going to build on the last, ensuring that the data stays consistent from the desktop to mobile. So form is where we're going to shape that data, building all the geometry, styling, and logic. And flow is going to be how we serve that data, running the same workspace automatically when someone requests that model. So these 2 components form the bridge between GIS data and the live AR scene. So inside of FME Form, we can convert our 2D GIS features into 3D. This is where lines can become pipes or cables, points can become hydrants, signs, or poles. So transformers like the extruder, pipe replacer, offsetter, and appearance setter are some of the most common tools that we can use for this. Everything is going to be written in consistent units when we're doing this to ensure that the model displays at the correct scale when it's in augmented reality out in the field. So geometry alone isn't enough. We also need to define where that model belongs. So the anchor point is going to tell Realize where to place that model, and the writer determines its coordinate system from that first feature it receives. So it's really important that all of the layers that you're writing share that same coordinate system. And that can be part of your QA QC process that Dan showed earlier as well. Just important to note. We can also attach key attributes as labels or interactive summaries that you can connect to in the field. So this might be things like identification numbers or maybe inspection details, things like that. And then we're in charge of the appearance as well. So any of the items that you write out, you can determine its color, what material, its transparency, and this will just make it easier for your field crew that is using and interacting with this data, easier for them to read that data, understand what it is, give them context. But it's totally up to you whether you want to use very simplistic shapes or you want to maybe spend more effort doing detailed textures. The level of complexity is up to your scenario and also your performance needs. So just keep in mind that a more detailed model is going to take longer to load. So if you have a big data set, this is something to keep in consideration. So on this slide, we see a fire hydrant going from probably a point data to a fully OBJ model to out in the field what it looks like. This fire hydrant is very realistic. It's great. Nobody's going to mistake what it is, but it could just as easily be represented by something like an extrusion or something like that. And honestly, probably a lot of your field crew will know what that is, or at least get used to seeing what that is, and it'll be a lot faster to load. But you can't deny these detailed models do look nice. So once that model is, once the data is modeled and styled, we write it all out to the FME AR format. This format packages everything together. So all of your geometry, its metadata, and its appearance into a single FME AR file. And the FME AR file is streamed directly to devices later on in the workflow when you're actually using FME Realize. So this single file acts as the handoff between FME Form and FME Flow. And when the workspace is ready, we publish it to FME Flow, just like any other FME workflow, whether we're publishing to an automation, a workspace app, a schedule, you just go through the same process. There's a couple different parameters to keep in mind though. We want to include any of the needed data files, and we also want to enable data streaming on that FME AR writer. Data streaming is what's going to make the workflow dynamic. So it's going to send that generated FME AR model directly to the Realize app. So this setup allows AR scenes to be generated on the fly instead of storing pre-rendered models. That has the extra advantage that your data is going to be up to date when you're looking at it in the field. So after publishing, we use FME Flow apps to create the Realize app itself. So from Flow apps, you create an AR app and select your workspace. You just customize the name, description, icon if you like. So it's very clear to your users, whatever they're opening. We can add instructions, we can use Markdown, links. We can kind of put as much effort as we want into this app or keep it bare bones. It's up to you. And we also need to choose where the geolocation is set. So this tells the app how to position that model when it runs. If device geolocation is turned on, it uses the phone or tablet's GPS automatically. This is great for field use. If it's turned off, the user can enter a location manually before it loads. And if the workspace already includes the default location, that model will appear there each time. For our example, we're going to use the device geolocation on, so the model loads right where the user is standing. You can decide whether to also show additional parameters or have the model launch immediately right here in the app. So once saved and you filled out just this form, the app becomes available in FME Realize for anyone who has permission to view it, and it's ready for use in the field. And when that app is opened in Realize, it triggers the same workspace in FME Flow, the same workspace that we built in Workbench. So the FME AR file is streamed back to the mobile device where it's placed in context using the device's GPS. Users can position or rotate the model to line up with real-world landmarks. And all of the summary annotations and links that we created now can become interactive. So tapping a feature might open a dashboard, a report, or a web page, anything that you've configured in that workspace. So everything put together makes the experience very visual, but as well as very functional. So let's look at this process in action with a real world example. In this example, field crews, often need to understand what's underground before they start work. So here our goal is going to be to show buried water mains and hydrants in context, not just on a 2D map. So this kind of workflow ensures safety in the field and adds another layer of check. We already have call before you dig, things like that, but it is so much better when you can augment that with a visual right there in front of you. Traditional 2D maps basically just make it hard to see how assets align underground. It requires a lot of expertise, double checking, triple checking. So with this workflow, we can use the same utility data that organizations already have and turn it into an accurate 3D model placed where they actually exist. So by building in FME form and delivering through flow, our existing data sets become interactive AR scenes that help crews plan and work safely in the field. And this demo follows, a similar 5 steps that we've just talked about. We're going to read and filter utility data for our area of interest, and then turn those 2D lines and points into 3D pipes and hydrants. We'll check the geometry at each step using feature caching, writing everything in the end to the FME AR format. Then we'll publish that workspace to FME Flow. Finally, that model is going to be streamed to FME Realize for viewing on site. And this process doesn't change too much. It's the same formula each time. It's a straightforward process that you can reuse for almost any spatial data set. So let's take a look. Okay, so we start in this workspace in FME form, and it's creating an FME AR file. We have fire hydrant and water features. Let's run it to see what that data looks like. So this first bookmark defines the area of interest for the model, and the feature reader is going to connect to a database and pull features that fall within the area. So a fire hydrant, for example, starts as this 2D point feature with attributes like an ID and a location. We can use a transformer like the coordinate extractor to read those coordinates for positioning. Then we have a feature reader that brings in a 3D model of a hydrant stored as an OBJ file. So we can take a look at that also in the data inspector. The data inspector has support for 3D. You can orbit, pan around. Then we're going to use the offsetter to shift that hydrant vertically so that it sits correctly on the ground surface. So this is another trick we can do just for better visuals and accuracy. Finally, we write that hydrant at a full scale to the FME AR writer. So let's take a look at the water branch. Now, water has a bunch of different features that we can each handle differently. So you can see here they are in the database, points and lines, basically. So for something like a water main, it can begin with a pipe replacer transformer. So the pipe replacer converts 2D lines into 3D cylinders. So you can see what that looks like here. Something like the vertex normal generator next would smooth that surface for a more natural lighting in the end result. And then the appearance setter, here we can just apply a blue color. This will represent water more intuitively to those out in the field. And again, we'll write that out to the water feature here on the AR writer. But different features require different representations. So smaller features like the pipes and, like valves and covers would use maybe smaller and more simplistic shapes. This will make it really quick to load and is ideal for larger data sets where performance matters. So a 2D ellipse replacer would generate a circular shape at each valve. And an extruder would extend that circle vertically, giving it this simple 3D form here. Together, that creates a really clean, lightweight 3D valve, something we saw, I think, in Dan's video. It looks really good out in the field. Again, we write that out to the same water feature in the FME AR writer. So here we create an anchor feature, and this anchor is a single point that tells Realize where to place the entire model. So let's publish it up to Flow. We're happy everything's being written. Here, we just want to make sure in data streaming that we've got that FME AR writer connected. We hit publish. We can go over to Flow now, and we go in the usual place. Here we have AR apps now underneath Flow apps. And creating an AR app is just as easy. You just select your workspace. Here we have the workspace we just uploaded, decide how geolocation is determined, and we can publish or save, and that's how easy it is created. And that's all you need to do to create a Realize experience from front to end. And this would work with all the other features that we had in that workspace as well. It's just the process of QA/QC, creating either 2D or 3D features, and giving an appearance and writing to that FME AR file. So just some key takeaways for anyone wanting to try this out. I would advise keeping your first scenes small, build some confidence before scaling up. You obviously don't want to handle every single feature all at once. Start with something small like that fire hydrant or a pipe or something like that and build from there. Balance realism and performance depending on your data volume and use case, as also keep your user base in mind as well. Maintain a consistent coordinate system across all of your layers that you're writing. Use feature caching to troubleshoot, verify each step before publishing. Our data inspector can handle 3D data best it ever can. Now we've added some features there to make it even better. FME Form handles all the creation, FME Flow handles the delivery, and Realize handles that end result visualization. And together they're going to create this seamless data to experience pipeline. So each step really builds upon the last in this workflow, from Dan's QA/QC all the way to delivering that app. And together they form this pattern for any FME Realize project. It's a simple, repeatable process that turns your existing data that you already have into something that you can see and understand in the field. I highly recommend checking out the tutorial that we have on creating these Realize experiences. We'll link it at the end, but it follows the exact same data that I just showed in this demo, so you can try it out yourself. Okay, and now I'm going to hand it over to Posh to talk a little bit about Philadelphia International Airport.
Awesome, thank you. So now that we know the steps to get to FME Realize, let's talk about the journey that we've gone through at Philadelphia International Airport and how we ended up using FME Realize. So a little bit about the airport. You can see here we have multiple logos. At the bottom right, that is the latest logo that was released 2 weeks ago. So a little bit about the airport. The Department of Aviation reports under the City of Philadelphia. We are a self-sustaining enterprise operating 2 airports. Our main airport, the commercial airport, is PHL, and then we have a general aviation airport, which is P&E. Just some facts about PHL. We have 126 gates, 7 terminals, 2,600 acres, and 4 runways. And then Department of Airports, which is DOA, you might hear me refer to as DOA. The DOA's Spatial Services team is led by Nora Doherty, who is our Director of Spatial Services. I report under her as the Data Integration Manager, working with BIM, CAD, and GIS. But our team support the entire enterprise, from engineering to planning to the leasing, and everything included with operations. And you all might have seen this graphic on the right side for project lifecycle, but we support everything along that, from planning, design, to building, and then operation. So for our project showcase today, we're going to talk about the Master Utility Drawings project, which you might hear me refer to as MUD. So from a legacy system standpoint, it includes of CAD to PDF record sets, and also paper copies, 75 pages of confusion. This update isn't updated frequently. It's every 10 years or so, and it's also not easily accessible. Some more pain points here. So we relied on printed copies and also PDFs. There's also numerous one-off projects in GIS and CAD. There's data scattered in multiple data silos. Unclear on which is the latest and greatest since we have it in so many different spots. No standardized workflow or documentation. And also the famous saying of PDF is where data goes to die. You know, it can't really be searched or queried. So we're just, you know, sticking things on a map and then throwing that problem over the fence and not looking at it again. So now in our most recent MUD update, which is still going on but started late last year, we wanted to focus on transforming these record PDF paper copies and 2D CAD and transforming them to AutoCAD Civil 3D pipe networks, as you can see in the graphic on the right, which is an IFC export from the Civil 3D model. We also ramped it up Autodesk Construction Cloud, ACC, earlier this year. So we want to maintain that data, our model data on the cloud as well. And then another workflow is Civil 3D to GIS, since a lot of our legacy system or our source of truth is really going to be living in GIS. And also come up with that change management workflow so we can upkeep this one source of truth. So the new way with FME, just a high level, how FME has helped us throughout this new journey. We have QA/QC of the pipe network data fields, seamless conversion from Civil 3D to GIS, and also that change management piece, which is the most important piece, is upkeeping future edits using the AutoCAD handle ID. So before we begin, we have to assess the data. I know it's a little bit fuzzy here, but the left arrow is basically all the CAD attributes that come in from the Civil 3D model from the pipe networks. And then on the second column, the second arrow, that's basically our GIS data schema. And this will come into play in the future workflow. But this would be helpful for your organization or your company to set up as you migrate CAD to GIS. So our first workbench is our data validation. So using that same data schema spreadsheet, we can validate the property sets within Civil 3D pipe networks. We're checking for missing data. We're checking for expected data. Also, we can do some technical checks with the slope and elevation. Sometimes when you model things, it might snap to elevation 0. And if you're modeling thousands and thousands of elements, you know, this is a quick way for us to do a quick check on the model elements. We can also generate reports and send that back to the consultant team working on this project and having them correct any issues. And FME, this FME workbench allows us to repeatedly check the data as they're coming through in different milestones of submission. Next workbench, we have our CAD to GIS workflow. So some of you might know Civil 3D does import into ArcGIS Pro. You might ask me why we're using FME instead of that Pro integration. Well, what I found is Pro does not pick up all the attributes that you might want to see, such as materials and certain custom pipe dimensions. So we're using FME along with that data schema spreadsheet to map everything and also rename to match that data schema. And then for our change management, starting from the far right side, we have our Civil 3D. So this would be any new projects coming on board that would be then updated in our federated or master model, which is that blue icon. So that lives in ACC. And then the red stop signs that you're seeing in the middle, those are all the different workbench that we have to track any abandoned pipe, demoed, additions or any modifications in the pipe networks based on the handle ID from AutoCAD. And from there, we'll republish it as a file geodatabase in ACC. And then our GIS team will take that into the portal integration. And then we can all live happily in one house using GeoBIM to see what's on ACC and also from the Esri environment. So we went from this, which is record plan set from PDF and 2D CAD and paper copy, to a 3D model in Civil 3D, and then publish in GIS into our ArcGIS hub. So the data is accessible to all of our DOA staff. They know what's going to be the latest and greatest information. We have, in this ArcGIS hub, we have a variety of different applications. You can see the entire master utility data, or you can go, if you want to focus just on electrical or water system, we have that as well. And the most important part is we have everything date stamped for the last updates. So everyone knows when that data was captured or updated in ArcGIS Hub. So, we asked ourselves, what more can we do with this data? I still remember meeting Dimitri last year, and then Don as well, at an airport conference that they were showcasing a beta of FME Realize. Well, it wasn't FME Realize at the time. We didn't have a name for it. But for me, I knew this MUD project was going on. And I figured this would, after Don walked me downstairs and brought out his iPad and showed me what is now FME Realize, I knew we would have to take this on. So our main wish list for this task is to take this data and make it accessible to those that are on the field. Something to easily locate underground utilities. I know we have field maps that can locate location, but AR really brings that data to life. And also, we wanted a way to sync up with GIS, updating field inspection notes and any status. So we want to test that out as well. So that's me outside the DOA office building, testing out a capture of the sanitary manhole, which we will now show a demo of. All right, so you see here walking around. So this is me holding up the iPad. We got the sanitary manhole structure. This is all the attributes that we had in data schema. Then we also have the middle one right now I'm clicking on, which is as-built attributes, and then notes. So right now I'm going to type in the note, testing 1, 2, 3. Submit that. Once I get the green, I'll go back to my attributes just to show that it's been updated on AGO, which you see testing 1, 2, 3 under notes right there. All right, so now we'll go ahead and test this out on the airfield. So the next video coming up. So now we have our senior GIS analyst out on the airfield, Adrian, looking at another sanitary manhole. looking at all the attributes here. So this is everything that was kept up from our data schema. And the reason why we have our as-built attributes is so for those that want to quickly just look at those attributes and locate the project on eBuilder or Trimble Unity Construct. And here is Adrian writing a note to myself and Dimitri. All right, so submitting the job, got the green light. and also thumbs up. Awesome. So benefits that we saw in FME Realize, we're able to have spatial context and real-world insight in the palms of our hand. Using AR, we're able to visualize that 2D because it's coming from GIS, so we can visualize that 2D map in the real world. As you can see in the video, we're improving field awareness and also safety as well. And then this really enhanced collaboration and communication. And part of our roadmap is to use FME Realize for Revit models. Any new, let's say, vendors coming inside the airport or any new building structures, we can use FME Realize to showcase that. And really, the seamless integration within FME environment. What really sold us on this is, we already have it in our subscription, right? If you have FME Flow, you have FME Realize. So who doesn't love free stuff? I do. So it was an easy choice for me to tackle this on. So what's next for us? Like I said, showcasing Revit models in FME Realize. We are completing a scan to BIM project at the airport right now. So I will be working with Dimitri to showcase that Revit model in FME Realize. I know he posted in the Q&A, we do need to use the manual mode while inside the building. So maybe I'll hop on a future webinar to showcase that once we have it ramped up. And I brought up earlier on with the as-builts, all of our as-builts are housed in eBuilder or now Trimble Uni Construct. I think we'll all say eBuilder for a few more years, but project information lookup, we'll have as-built data, owners manuals, and also shop drawings. With that, thank you.
Amazing.
I'll pass it over to you.
Awesome. Thank you, Posh. Yeah, really appreciate your time sharing today's use case. Just looking at all the emoji reactions and slew of interesting questions, I think the audience got a lot of value out of the use case and the content you shared. So thank you so much for your time. We do also have Posh's email on the screen here if you have any follow-up questions for him. But that said, I'm aiming for at least 5 minutes at the end here to answer a couple questions live. And then of course we've been answering as we've gone here in the questions tab as well. But just to wrap us up here before we get to questions, if you're newer to our company, Safe Software, we've been in the data integration game for over 30 years across over 25,000 organizations across the world. In terms of resources to help you get started with next steps after today's webinar, we have a couple tutorials linked here, as well as a more full-length Watch FME Realize in Action video by Dimitri for more scenarios there. And just a reminder, you can download this deck on the top right of the PDF and click through those links there. Yeah, maybe I'll actually pass it over to the team in case anyone has other notes to mention on these resources. We'll open the floor in case.
Yeah, I linked the QA and data validation with FME article. I think it's just a great resource if you're looking into doing that. Lots of information there on different spatial validations, especially.
Well, maybe if you watch that 9-minute video, you will see almost everything what's possible for the outdoor scenarios there. And maybe I can say a few words about that in general. Because, answering Michael Olam's question, for large assets, can you utilize multiple anchor points as the area could be spread out over miles? So the whole idea is that we don't pre-generate any data. So if the whole point of being connected to FME Flow is to generate data for that location and only where it's requested. So you go anywhere in the city, and that is proven. I have 2 cities sitting in my databases, in the regional databases, just flat GIS data points and lines and nothing else. I can go and at any intersection in those 2 cities, send my location to FME Flow and get back model within 15-20 seconds, get back a model of within 100 meters of that particular location in 3D, draped to the surface and working the way I want. So that's the main idea for FME Realize. And maybe I can answer a few more questions while I'm speaking. So another question was, does it make sense to prep to the prep of 3D data to drape to elevation? And I mentioned that yes. So Vancouver, the Metro Vancouver area is pretty hilly. It's next to the mountains, and we have to drape. Otherwise, it looks really bad. You walk 10-20 meters, and then suddenly your pipes are above your head or really deep under the ground, and that does not bring the effect of seeing under the ground. It just makes it look weird. That's why I usually put the utilities on the surface. Then was a good question. Which one? Does data streaming occupy an engine? Yes. To generate that data set, you need a workspace to run. So, and that's an engine, but that's only for the duration of generating the model. While when the model goes to your device and displayed there, so the engine is free. And so it's up to us, the workspace designers, to make those workspaces work fast. So if you use feature reader, for example, within your workspace, make sure that you clip to the extent of your initializer. So you would send your location, buffer it, say 100 meters, and you would clip your huge data set to only that specific location. So if it's a spatially indexed database, it will be like really fast. I tried shapefiles, I tried geodatabases, I tried spatial light, so it takes just seconds. Even if you have a few millions of objects, it takes just seconds if you use feature reader with that clip option. A good question was if I'm lazy, I am, can we stream just lines and points instead of volumes? No, you have to transform the data to 3D to generate either meshes or surfaces or solids. And we have a few transformers for that. Pipe replacer, for example, and Sanai mentioned, creating a circle and then extruding it, or you can replace points with small, well, not small, real size models of the object. That's also a possibility. But you have to decide whether you want to stream them, because if it's something on the ground, like a fire hydrant, yeah, you don't want to stream the whole model of a fire hydrant anyway.
Okay.
Yeah. One last question. Any success using Realize indoors? And Posh mentioned that we would like to use Revit. So, but yeah, we have to manually adjust the model location. We will place it on the surface, on the floor, but rotation and offset, you will have to do that. It will be, well, the location will be fine if you follow certain rules, but rotation usually is bad within the GPS devices. The compass is not good. Indoors, it's even worse, so you would have to rotate the model.
Amazing. Okay, and I think we'll have time for another question or two as well live here, but I'll just walk us through the last of our next steps here. We do have a bit of a call out here to download FME Realize on the App Store. I believe if you just search FME Realize, that will come up. So yeah, I encourage you to do that if you have yet to do so. Our FME Accelerator, if you're new to FME, it's a great place to get started. 90 minutes free of charge. Our community badge code, if you're a member of our community, we have a code for today's webinar as a thank you for joining us. It's a great place to also network with other users alike over at the community if you aren't yet a member. Okay, so with that, I will pass things back over to the team once again here. and we can address a couple more questions here live if we want to come back on with our webcams to wrap up and get to a couple more questions. I see we've gotten a few more come in since we've answered the last few in the chat. So maybe we can pick out one of those.
Okay, so Kyle Lander is asking, any possibilities for using registration points for indoors, like targets on walls to locate the model? We are working on that. No promises about anything, but yes, it's a request that we see coming from those who try to use FME Realize for indoors.
Great.
And in general, if you have questions about FME Realize, feel free to send me an email, Dmitry@safe.com, DMITRI@safe.com, and I'll be happy to help you.
Amazing. Yeah, and that said as well, now's a good time to mention if you do have questions that come up after the webinar, we will stay online for a couple minutes past the hour and be able to answer in the chat, or we'll follow up after the webinar as well. Okay, awesome. Well, thank you so much, everyone, for your time today. We really appreciate you joining us. If you do have a moment to leave us any feedback, we really appreciate it. It helps us improve the program. Let us know what you thought of the webinar today. I just dropped the link in the chat as well. But without further ado, we hope you have a great rest of your days ahead. And thank you so much for your time, as well as our presenters' time. And Posh, thank you for your time and joining us and sharing today's use case. Awesome. Thanks, everyone. Bye for now.
Thanks, everybody.
Thanks.